let me take this opportunity to explain you about the freezing point depression method in order to calculate the quantity of NaCl. This freezing point depression method, if I am not wrong, you have already studied in either your first year or it was there in your physical pharmacy also. In your second year also you had freezing point depression method. Okay, I just thought of revising this freezing point depression method for you. How you are going to calculate the quantity of NaCl, directly writing down the quantity of NaCl over there, okay, and telling you that this is the formulation. I thought to explain you how this freezing point depression method is being used. What I am going to do is I am going to take the example of procaine hydrochloride. I am not going to take the example of atropine sulfate. I am going to take the example of procaine hydrochloride. What I want you to do is you take a notebook, take a pen, okay, and then write down the method of calculating of freezing point depression. And then I am going to give you an assignment which you have to do in this practical only, where you have to find out the freezing point. You have to calculate the quantity of NaCl that is required in the formulation. And then what we are going to do is then we are going to replace this, okay, with the quantity that you have calculated. I hope I am clear. I hope you have taken your notebook, you have taken the pen. Let us start with I'll explain in a very simple way how you are going to calculate the freezing point depression method. First year में या second year में आप you are quite young. Many times many of the students don't understand the freezing point depression method, and this is important from the point of view of your GPAT examination also. In GPAT examination also many times the question on freezing point depression comes. Okay. So let us take the example of procaine hydrochloride. Understand this properly because you have to do an assignment. Now, the formula for procaine hydrochloride is procaine hydrochloride we have taken 2%. ये percentage कितना लेते हैं ये बहुत important होता है. Okay, how we will be studying further. And the quantity of formulation is 5 ml. So this information is required by you. So 3 informations will be given to you. The percentage of the active ingredient that is being used, the quantity of the formulation, and the freezing point of that particular substance would be given to you. So the formula is of procaine hydrochloride 2% and the quantity formulation that is used is 5 ml. Now in the step 1, what you are going to do is you are going to calculate the freezing point depression of procaine hydrochloride. So आप पहले what is the freezing point depression of procaine hydrochloride that you are going to calculate. Then you are going to calculate the difference between the freezing point depression of procaine hydrochloride and your blood solution. Okay, body fluid. That difference you are going to calculate. पहले आप इसका freezing point depression calculate करोगे procaine ड्रग का, बाद में ड्रग का और whatever is your body fluid उनका जो difference है that you are going to calculate. And then you are going to see how much quantity of NaCl is required to make up this quantity. Okay, this freezing point depression. Now both freezing point depression and your isotonicity etc. they both are colligative properties. Okay, as they both are colligative property, hence once you adjust one, the second would be adjusted automatically. Okay, hence we are trying to adjust the freezing point depression over here. As soon as you adjust the freezing point depression, your isotonicity is also going to get adjusted. Okay, that is what is the principle that we are going to use over here. Okay, let us go with the step 1. I hope you are ready with your pen and paper. Your step 1, you are going to calculate the freezing point depression of procaine hydrochloride. So what you are going to do is this value would be given to you. What is the freezing point of procaine hydrochloride? Freezing point of procaine hydrochloride is negative 0.122 degrees Celsius. This value is given in your literature. Okay, even if you Google it, you will be able to find out, right? Now, therefore, this is freezing point of procaine hydrochloride. So the freezing point depression of procaine hydrochloride would be 0 minus of minus. So you are going to subtract this from 0. So it will be 0 minus of minus 0.122, which comes to as 0.122. The negative sign goes out. So the freezing point is negative 0.122 degrees Celsius, whereas the freezing point depression is negative of negative, that is 0.122 degrees Celsius. I hope this point is clear with you. Now all these values, whenever the freezing point values are given, they are given for usually 1% of procaine hydrochloride. Okay, now for 1% of any drug. So for 1% of procaine hydrochloride, the freezing point depression is 0.122 degrees Celsius. But the formula contains 2%. So 2% of procaine hydrochloride has freezing point depression of 0.24 multiplied by 2. So 1% का इतना है तो 2% का कितना होगा? If the formula contains 5%, then 5% का कितना होगा? If the formula contains 0.5%, then it is going to be half of it. Okay, accordingly you are going to calculate. This calculation can be done with your cross multiplication also. Okay, this is very simple. So for 1% it is 0.122. Therefore, for 2% of procaine hydrochloride, the freezing point depression is going to come as 0.244 degrees Celsius. I hope you are able to understand the freezing point depression of how we have calculated the freezing point depression of procaine hydrochloride that we are going to add inside the solution. So अभी आपके solution का जो freezing point depression हो गया है वो 0.244 है, लेकिन but the freezing point depression of your body fluid is near about 0.520 degrees Celsius. So there is a difference. Freezing point depression of your solution because of procaine hydrochloride is 0.244, sorry, 0.244, right? Whereas the freezing point of your body fluid is 0.520. This is well known. Okay. So 2% of procaine hydrochloride has freezing point depression of 0.244. From here we have taken this sentence. Body fluid has freezing point depression of 0.520. So the difference between the freezing point depression of body fluid and procaine hydrochloride is 0.520 and 0.244. Isn't it? So difference that comes is 0.296 degrees Celsius. That is the difference, okay, in the freezing point depression. Kindly go through this. If you have not understood why we have taken 2%, that is the formula, beta. Because 2% is going to show the action. Sanjana, ये formula है. आपने like you take any. Why do you take paracetamol 500 milligram? Because 500 milligram shows the action. Okay, that is the quantity of drug that is required in order to show the action. That's why procaine hydrochloride, when present in 2%, it shows the action. So this formula is known to you. Understand? The formula is known to you. Right? Any other query you are having, please do ask. Any other question? Have everybody understood? Those who have not understood, please write down in chat box that you have not understood. I will explain it again. Can you explain step 1 again? Which step you want, Ritika? Can you tell me which step you want? Step 1 means the whole step you want? Okay, I will explain the whole step again. 178 from 1B. Okay, no problem. No problem. I'll explain you full. Now, in step 1, what you are going to do is you are going to calculate the freezing point depression of procaine hydrochloride. That is the step that you are going to do. In order to calculate the freezing point depression of procaine hydrochloride, the data that you require is freezing point of procaine hydrochloride. This data is available in your literature. From literature, we have found out that the freezing point of procaine hydrochloride is 0.122 degrees Celsius. This is freezing point. We want to find out freezing point depression. So please, when you are taking the data, see what you are seeing. Whether you are seeing the freezing point or you are seeing the freezing point depression. Okay. If you have the value of freezing point, then freezing point depression is negative of this sign. It is 0 minus. This is 0 minus, okay, this value. So 0 minus this value comes to 0.122. The negative sign, it goes off. Mathematics. Okay. The negative sign, it goes off and it comes to ऐसा याद रखना, जो freezing point है उसका जो opposite sign है, that you have to give for the freezing point depression. Usually freezing point is negative only, and usually freezing point is positive. That ज़्यादा करके. So this you have to remember. Now these values of freezing point, whatever are available in literature, they are always for 1%. Okay, they are always for 1%. So this value, whatever is available, is for 1%, right? Am I clear now? So what we are trying to do is, for 1% procaine hydrochloride, the freezing point depression is 0.122 degrees Celsius. This we have obtained from the literature. Our formula contains procaine hydrochloride 2%. So we are calculating the freezing point depression for 2%. So अगर 1% के लिए 0.122 है, तो 2% के लिए 0.244 होगा. अगर यहाँ पे 3% दिया होता प्रोकेन हाइड्रोक्लोराइड, so for 3% it would be 3 multiplied by 0.122, so it will be 0.366 if I am not wrong. अगर यहाँ पे 4% होता formula, so you have to adjust up to 4% of procaine hydrochloride will be giving you the freezing point of 0.4 something multiplied by 4. So whatever value comes after multiplication of 4, that value would have been over here. Are you understanding? Am I clear now? Okay. This is your step 1. So now in step 1, what has happened is you have calculated the freezing point depression of procaine hydrochloride. Okay. So this is the freezing point depression of procaine hydrochloride. In step 2, what you are going to find out is the difference between the freezing point of your substance that you are adding and the freezing point of your body fluid. Freezing point of your body fluid is 0.520. Again, this is given in the literature. This is constant given in the literature. This you have to remember. And 2% of procaine hydrochloride, we have earlier calculated the freezing point depression is this much, 0.244. So what we are trying to do is we are going to find out the difference of freezing point depression of your body fluid and the procaine hydrochloride, the drug that you are using, 2% of procaine hydrochloride. You are going to find out the difference. So the difference is 0.520 minus 0.244 degrees Celsius. And the value comes after differentiation, the value comes after subtracting, the value comes as 0.296, which you are going to use further. Have you understood now? Any problems still you are having? Anybody? Anybody who has not understood? Fine. Let us now move further. If you have understood up to this, now in the first step, again I am repeating, in the first step we are calculating the freezing point depression of procaine hydrochloride. In the second step, we are calculating the difference in freezing point depression of procaine hydrochloride and your body fluid. Okay, and we derived to an answer of 0.296. Moving ahead. Now let us calculate now the quantity of NaCl. ये सब हमने क्यों किया? Because we wanted to calculate the quantity of NaCl that is required to be added in the formulation. 0. Again, this is a standard value that 0.9% of solution of NaCl gives you is isotonic with your body fluids. बराबर है? ये हमने बहुत बार पढ़ा हुआ है. That is 0.9% solution of NaCl is isotonic with your body fluid. If it is isotonic with your body fluid, it also means that 0.9% solution of NaCl is going to have the same freezing point depression as of your body fluid. It also means that 0.9% solution of NaCl gives freezing point depression of 0.520. Am I clear? So this sentence you have to again remember that 0.9% of NaCl solution gives you freezing point depression of 0.520. So how much percent of solution, if you add, is going to give you freezing point depression of 0.296. Why we are saying, why we want the freezing point depression of 296 to be added? Because that is the difference. आपका solution का पहले ही freezing point depression 0.244 है because of procaine hydrochloride. The difference that you have to adjust is 0.296. This difference of 0.296, how you are going to adjust? You are going to adjust with NaCl. So we want to find out the quantity of NaCl that will be required in order to have the freezing point depression of 296. If cross multiply x into 520 and your 0.9 into 0.9296, if you cross multiply, you will get the value of x. So x is going to be 0.9 into 0.296 upon 520. If you do this calculation, then you get the value of x as 0.51%. So 0.51% of NaCl is required to be added in your formulation so that you get the value of so that you get the you make the preparation isotonic with your body fluid, so that you make the freezing point depression similar to your body fluid of your formulation. Now let us calculate the quantity. Abhi 0.51% solution you have to add. It means what? 0.51 grams of NaCl is required to be added in 100 ml because it is in percent. So 0.5 ml of NaCl is required to be added in the 100 ml to make the procaine hydrochloride 2% solution isotonic with your body, with your eyes, okay, with your body fluids. But the quantity is 100 ml, right? The quantity of the formulation is 5 ml. If you have seen over here, this is the quantity of 5 ml. So in 5 ml, how much you have to add? अगर ऐसा क्वेश्चन आता है, अभी right over here you can easily write down as over here you can write down as now in the formula you can write down as 0.51% solution. This you can write down, okay. But supposing आपको पूछा जाता है, so this is going to satisfy your formulation aspect that it comes to 0.51% of sodium chloride. With 0.51% of sodium chloride, you are going to make your solution isotonic with your body fluids. Okay, so this problem is getting solved over here because these quantities are in percentage. Let us assume that these quantities are not in percentage. Okay, and this is not 100 ml. Okay, अभी 5 ml के लिए आपको कितना चाहिए? अगर मैंने आपको पूछा, you are preparing just ampoule of 5 ml. So for 5 ml, how much you are required? So for 5 ml, you are going to calculate this quantity. For 5 ml, you are going to calculate this quantity. So for 5 ml also, you have to calculate this quantity also. So how you are going to calculate this quantity? So 0.51 gram of NaCl is required in 100 ml to make procaine hydrochloride 2% solution isotonic. From this, we have used this formula because it is 0.51%. So 0.51 gram in 100 ml we have to add. So in 100 ml, we have to add 0.51 grams. So in 5 ml, how much grams you have to add? Again, if you cross multiply, you get y is equals to 5 into 0.51. So this is cross multiplication upon 100. So it comes to 2.55. If you multiply this, comes to 2.55 upon 100. Okay. So again, if you divide it, it comes to 0.255 grams. If you want to convert it into milligrams, you are going to multiply it by 100. It comes to 225.5 milligram. So the quantity of procaine hydrochloride, the quantity of NaCl that is required to be added in this formulation, which contains 2% of procaine hydrochloride and 5 ml of your vehicle, the quantity that is of NaCl that is required to be added, okay, is how much? It is, if you see over here, it is 25.5 milligram. So in this formulation, if I add 25.5 milligram, okay, of your what you call that NaCl, then my solution is going to be what you call that it is going to be isotonic. ये मैं फॉर्मूला अलग वे से भी लिख सकता हूँ. If I don't want to do the further calculations, I can write it in other way also. That is 2% of procaine hydrochloride, okay, and NaCl as 0.51%. and the quantity is going to be 100 ml. Okay, so this is the formula. This is the way that I am going to write down the formula, or I can write down the formula as 2 gram of procaine hydrochloride. Okay, then sorry, 2 gram in is going to come in 100 ml. बराबर है? 2 gram is going to come in 100 ml. So 5 ml में it is going to be how much? So 5 into 2 becomes 10 upon 100 becomes 0.1. So I can write down this formula as 0.1 of procaine hydrochloride, 0.1 gram. I have to convert it again to milligram, that we can convert afterwards. 0.1 gram of procaine hydrochloride. Okay, and then 25.5 milligram of water. 25.5 milligram of NaCl and 5 ml of water. Okay, in this way also we can write down. I am not confusing you much into this, but those who have understood, that it is okay. If you have not understood, also it is okay. So just to go with the last part once again, you have already found out the difference of freezing point depression. Okay, now 0.9% solution of NaCl gives freezing point depression of 0.520. This is the standard sentence. Okay, and then we have found out the percentage of solution of NaCl that is required for freezing point depression to make as 0.296 by cross multiplication, which was 0.5%. 0.51% we converted into later into milligrams. Okay, this, as I said, can be done if you don't in your formulation, depending upon what the question is there in GPAT. You have to see and you have to find out. Then final answer is 25.5 milligram of NaCl is required to be added in 5 ml of procaine hydrochloride 2% solution in 5 ml. Please remember. Okay, अगर यहाँ पे ml करना है मुझे, it is very simple. It is going to be 0.51 grams, okay, of NaCl is required to be added in 100 ml of procaine hydrochloride. Okay, have you understood? Okay, fine. और उसके बाद में आप मिलीग्राम में भी कन्वर्ट कर सकते हो इसको, ठीक. So in 5 ml of procaine hydrochloride solution to make the solution isotonic with body fluids.